All right, we are officially live and very excited about this. Jason, Gary, how are you today?
All good, thank
Excellent.
you.
Excellent, Mickey. And I'm excited for this part. In fact, you're going to have to keep me in check like last time.
We are delighted to have you on this session, Gary. That is absolutely a pleasure and an honor. So really, really good. So I'm seeing the participants are slowly, numbers are going up. So we're just going to give everyone a couple of minutes. I know it's right after lunch, so hopefully everyone's been able to finish their lunch and grab a coffee. Or whatever else, tea or water for the session. So a couple more minutes and then we'll get started.
Well, and just Mickey, part of the reason why why I'm looking forward to it is when we've done this, we've touched a little bit on what's happening in the future, et cetera. And as some of the large language models came about and people became a bit more familiar with it, especially with things like ChatGPT, all of a sudden, some of this was a bit more tangible, although obviously our R&D teams were talking about this for a long, long time. So today, when we talk about this now, people can relate to it a bit more. There's been a more tangible aspect of it. So that definitely keeps it fun.
Yeah, absolutely. And I think it's always fun to, when we get the chance to talk about, last session, we sort of more focused on the history and where we came from and kind of where we are today. But I find, in this industry and technology, it's always fun to talk about the future, right? Like, where are we going? And I think that's a really, really cool way to, it's exciting. It's exciting to know what we're able to do and all the abilities that are coming our way. So it's super, super cool. All right. So maybe give one more second. 103 and 30. We'll start. Okay,
and I know there were questions about the recordings. The recording for session 1 is already available. Obviously, this one will be available as well. Similar to last time, any questions you have, we'll try to intertwine throughout the presentation. And if not, we'll try to cover them at the end in terms of however it comes up. Definitely, I like that this group was not shy about questions last time. We encourage the same for this time around.
Exactly. Absolutely. Absolutely. Okay, so I think we can officially get started. So welcome everyone to session 2 of our AI certification course. We're super happy to see your return for what is, as we kind of alluded earlier, is a super exciting session in this very exciting series. So we really hope that you enjoyed session 1 and had many takeaways, whether it was thoughts or some breakthroughs or anything that you can apply or think about as you kind of move through the next couple of sessions. So just a reminder for those who asked the question, session 1, we'll definitely send that summary with all the answers, so you're not left wondering or pondering on those at all. So, of course, if there's still any questions you may have on session 1 that you didn't get a chance to ask, feel free to email us. So you're going to see our emails pop up at the end of the presentation itself. So, quick reminder. So we covered this in the first session, but in case you weren't there, our certification course consists of 4 one-hour sessions. So this is week 2, and we have 2 more to go after this one. The sessions are very much designed, as Gary mentioned, to be interactive. So please just make sure you ask questions along the way. We always do try to leave time for questions at the end, if you prefer that, but we really like to make this interactive, and we'll answer as many questions as we can as we go along. So please fire away. So in last week's session, we, as we mentioned, dug into the history of machine translation. So I won't spend too much time on that, as I will do a quick session recap. And Jason, we can just go back one really quickly. So today's session, what we're going to talk about is really the continuation of that journey we started in session 1. So it's almost, going from past to the present in session 1, and now we're really going to talk about the future of machine translation and some super interesting and what I think are super powerful innovations. And then in session 3, we're going to show you how to successfully implement AI-powered translations in your companies, some key success factors, and maybe things to watch out for during the implementation so you can ensure that that's successful. And then lastly, in session 4, we're going to conclude it with showing you some actual real hands-on applications of AI in the translation industry. Okay, now let me really quickly summarize and recap what we talked about in session 1. So we gave you a glimpse of the history of machine translation that really started in 1949 with the memorandum on translation, and then we went all the way to the current state with the introduction of the transformer model. Then we talked about the types of machine translations from rule-based, we moved on to statistical, and then finally neural machine translation. And then, of course, naturally, our focus turned to AI because that is one of the hottest topics today, and really how our world has been completely reshaped by the current technologies within the AI space. We also covered this very, very high importance of data security, very, very important confidentiality, super critical points of early technology adoption for a number of reasons, from being a first mover or having the first mover advantage, and ultimately pure ROI on the business side of things. And then we give a very quick teaser on what we're going to talk about today. But before we move on with the session, just for those that did not join us in session one, I did want to do a quick intro of who we are here at Alexa Translations. So for those who may not know us, we help the world's most prestigious organizations in legal, financial, and securities industries to truly break down language barriers by providing both professional translation services on one end, as well as innovative machine translation platform that's specifically trained in those domains I just mentioned. And is evident by, as you can see, by the number of the awards you see here, the legal domain is certainly quite important for us here at Alexa Translations. So with that, it is an absolute pleasure to introduce your instructors for today. And today is a very special day because we not only have our resident expert, our product manager, Jason Cox, but we also have our chief, Gary Kalatsi, the CEO of Alexa Translation. So Gary, super cool you're here. It's an absolute treat to have you with us. I really appreciate the time for you to join us. So maybe Gary, for those of you who may not know you, perhaps a quick introduction, and then Jason, you can do the same after Gary.
I'm Mickey. I appreciate it. So, for background to the team, I got into the language space by starting as a court interpreter and then doing some translation. Eventually, became a lawyer, but only to realize I enjoyed translation a lot more and the business aspect of it. So, this is what led to where we are today. We started as a professional services firm, and naturally have a deep appreciation for the work that translators do and are very protective of it. So as we actually invest into the AI space by an acquisition we did in 2018 that has grown substantially since, it was really the mission was, how do you marry it to the really professional translators that have the experience, know how to do the proper research, really bring it all together and produce a really good product and make their lives easier by getting some of the mundane work that they spent a lot of time on, some of the work that was in tight timelines that felt really heavy and really a bit of a nuisance, and replace it with AI. So this has been our mission, and it's I enjoy spending time with translators because as a demographic, they're the people that understand this the most because they can truly appreciate all the nuances of it, versus when people are just bilingual or even less so when they are unilingual. It's much harder to appreciate some of these. And as anyone in this audience can probably say, just being bilingual is very far from being a translator. And that's why I enjoy this, spending time with translators. Thank you, Mickey.
Amazing. Thank you so much, Gary. Really appreciate the time again. And Jason, perhaps a short intro from you as well.
Yeah, so I think people will have caught the first session, or we'll be reviewing it as part of the certification course. But I got my start in corporate software and spent a little over a decade doing that sort of on the IT sort of help desk type softwares that support those groups, and then moved to translation 11 years ago, and I've been following the developments of machine translation and AI ever since, and those have been a very critical years in the history of machine translation, and it's been really exciting to watch it evolve. And really to see that we're able to make good on a lot of the promises that were made over a decade ago. So we'll be going into a little bit more of that today.
That's great. Thank you so much, Jason. Thank you. And for me, my name is Mickey Velimirovich, and I'm the head of product here at Alexa Translations, and I will be your moderator for today's session and frankly, the rest of the session. So hopefully you like the sound of my voice. I'm relatively new to Alexa, but I've been in the product and marketing industry for over 20 years, during which I've kind of had the opportunity to lead a number of global projects for a number of organizations, from enterprise level to small companies. And fun fact, so I used to be a client of Alexa's when I was responsible for product management in Mercedes-Benz. This was a long time ago, about 10 years ago, and now it's honestly a pleasure to be part of the team. And what's also cool is the Mercedes is still a client, so that's a testament of the commitment of this organization to its clients. So super excited to be here and really excited to get kicked off. So before I pass it on to the instructors, I just want to walk you very quickly what you can expect from today's session. So ultimately, what we mentioned earlier is we're going to talk about the future of neural machine translation. It's super, super exciting because we're introducing two major innovations in this space. And because I don't want to steal the instructor's thunder, I'll be super brief on these. But what we're going to start with is something called adaptive translation, which is a really powerful, advanced approach to training of the neural machine translation engine. And then we're going to lean in and walk you through something called LLM optimization, large language model optimization, which is really how can we optimize the translation output with an integration of these large language models. So super exciting. Today we're talking about the future, and super excited to pass it over to Jason and Gary.
All right, thank you. And so as mentioned before, definitely feel free to put your questions into the Q&A interface. We'll try to get to them as they apply to the content in real time. And then, of course, we'll respond to them more after, to as many as we can. And then any that we can't get to, we'll be in touch after the session and give you the answers that you need. So let's start with adaptive translation and what it is. So this is a kind of a broad topic because the terminology is somewhat vague. And so it can apply to a lot of different things and has been applied to a lot of different things across the industry. And so we're going to be kind of explaining that a little bit more and giving you a history, giving you an examples of all of the different things that it can, that terminology can be applied to. And so adaptive translation in the short summary version is a way to improve your translation and have it adapt to your specific context. So to really make it work with you on a daily basis, so that the things that you're teaching it, by making corrections, by changing the way that the style of certain segments or certain content within a document, it learns to do that better over time, so that you don't have as much of that repetitive work to do. The entire purpose of this is to make the translators' lives easier by delivering a result that adapts over time to be more like what you would have edited it to, but on the first draft. And so historically, the way that you adapt a translation or adapt a translation engine to a specific context, to a specific domain, to a specific region, is by obtaining enormous amounts of data, north of 10 million unique, high quality segments, and training the engine with that in a very formal machine learning way, where all of the training data is present at the beginning. Test data sets are extracted from that and not included in the training data set. And then you provide a bunch of different parameters that we kind of discussed in session 1. And then you turn the machine loose. It iterates over that data countless times, and it develops an inference. It develops a language model based upon that. And so using that model, there's a time during the training when essentially you've reached maximum amount of quality that the machine can get by iterating over the data, and then at some point it will start to degrade. you can look up concepts such as like overlearning or overfitting to the model, but there's a sweet spot, and that's sort of the process with neural machine translation. And so that's the historic way to do it, but that has a bunch of different sort of drawbacks, in the sense that there's a long delay before the model is ready, before the users can obtain a sufficient amount of information to trigger this kind of training. And then there's an enormous amount of infrastructure kind of delay with it as well. All of these things need to be hosted independently. All of these things need to be QA'd independently. So you end up with a situation where the engine does improve over time, but it improves in large increments over larger amounts of time. And adaptive translation is the technology that closes that gap. And it allows the adaptation to happen in a much quicker way. And so some of these customizations, as we'll go through in the methodologies, were in terms of more like direct matching. And if direct matches were not found, it really was in terms of fuzzy matching, it relied on the review and edits of a translator to kind of take the fuzzy match and adapt it to be the right kind of match. Now, adaptive translation can fill that role and start to make it so that segments that it's never encountered before and that the translator has never provided input on can be automatically edited based upon the inference that was made. And so this requires a smaller amount of data and can be done significantly faster. And so we'll be going into a lot more detail on that.
And Jason, if I can jump in, because there was a really good question from the audience, essentially saying, what is the difference between translation memories and adaptive translation? And I think it's an appropriate time to talk about it. It's something that I had actually asked at one point. And the good news is you don't have to pick one or the other. In fact, the two work well together, and they're both needed in their own ways. And Jason, I will give a first shot at the explanation. Please feel free to fill in the blanks. So essentially, translation memories, think of them as your rules, the things that when you see word A in the source language means word B in target language, or whether it's word, whether it's phrase, entire segment, etc. Now, adaptive, and you will recall this from session 1, when you're actually training engines, you're training a logarithm, which also means that when it actually, the training data we're used to train the machine to come up with as a logarithm don't necessarily regenerate back the same way. So if you used a particular sentence to train it, when you put it through and the tool is trained with it afterwards, it won't necessarily produce the exact same translation. It'll bring something very close to it based on the overall scope of the data it's been trained with. So logarithmically, you would need the adaptive engine that gets a flavor from overall data, and then the translation memories for very specific items that you want to keep consistent. I hope that's helpful. And Jason, please feel free to add anything further, because I think that's a really good question.
Yeah, and great explanation as well. And so it's kind of like, imagine if you were wanting to ask a question and you did it by doing a direct search in an encyclopedia, as opposed to asking a question of someone who's read a book on the subject. You're going to get a direct match that may or may not be exactly what you're looking for, or you're going to get the benefit of some learning on the subject.
And Jason, I'll provide a little bit of further clarity that adaptive translation doesn't have anything to do with large language models. So adaptive translation is the technology where you actually get new data to retrain your logarithm consistently so that the tool keeps evolving for your purposes. And before, and when I say before, even a year or two ago, this was done in a sort of segments that in increments that could have been months in between trainings. Whereas right now, this can happen in a matter of hours. And this is partially because of where we are in today's technology, but also as long as there's sufficient data, it can happen in real time that quickly. Large language models will have a different scope altogether, which we'll get to later in the presentation, but they are two different technologies that also can be used congruently without competing with one another.
Really, really good point. Definitely. Okay. So let's talk about how it works. So essentially, to sort of boil it down, you're starting with the base engine, and then that engine needs to be trained on. That's the one that represents a very, very large amount of data, so that the engine can extract a lot of information about the language itself and the rules of the language, the structure of the language, and the way that the different languages relate to one another in terms of translation. So that base engine is very important. But then the translator's input, which is again also used to train the base engine in large batches, but in the context of adaptive translation, even much smaller amounts of translator information is used to influence a layer of that base engine that allows it to adapt much more quickly to reflect the preferences for the specific context or domain. And so it starts with the broad range training material, then adapts with the post-editing data, and then the result is a newly trained engine that reflects the preferences of the translator in that specific domain or context. So it is very, very complex technically, but conceptually, the benefit that you get from it is just a much faster adaptation to the context. Okay, we'll go to the next one. And so this is something I alluded to on the first slide, and is that the terminology of adaptive translation is, there's not a specific rule as to what it must mean. So it can mean a variety of different things. So the translation memory matching that Gary was mentioning, that has and can be sometimes referred to as adapting or adaptive translation. It's not AI. It's not dynamic. It does still definitely have uses, and the two definitely still work together. But it's sort of an early version, but it has, you may have heard adaptive translation and had it really been referring to translation memories or term bases. The next level is sort of document level adaptation, and that is where it's doing a little bit more of what I was describing, of observing the kind of edits that you're making, and those edits, if other segments in the same document are contextually similar to those segments, it's going to start providing answers that are more specific to that, to the content that it's seen so far. However, it resets at the end of each document. It's still a useful technology, and it still reduces the post-editing time, especially if you're working on a very large and especially very repetitive document. However, over time, you're not benefiting from document to document. So that brings us to this last technology here, and that is where we keep the learning persistent from document to document. So this is as the post-editing data accumulates within a specific context, then that adaptation is preserved. And so the next document that you do, consider that you're working on a certain kind of document over and over, a certain kind of securities document, a certain kind of financial report. then there is a pattern to it. And so even though the content of the document is different, the spirit of it is similar. And so it's really beneficial to maintain that adaptive engine from document to document. And it's possible to have multiple adaptive engines that apply to different specific contexts. And kind of you're probably familiar with this concept in terms of you want to make a different adaptive engine for any time where the exact same source text would be interpreted differently in another context. So that's kind of where the divergence happens, to where you could really benefit from having more than one adaptive engine. It's the same way that you would probably benefit or probably determine on your own that I need to keep these translation memories separate from these translation memories. The translation memories that are used by the legal team may be separate from the translations used by the marketing team, for example. And so the same way that you would separate those kinds of resources, you may also want to separate your adaptive engines. And it's very, very possible to do so. So that as you choose to use one specific adaptive engine, all of the post edits that are made within that engine, it learns from that. And then you can switch to a different engine at any time. You can use them concurrently, that kind of idea. And so multiple engines are learning simultaneously about different contexts and can continue to evolve.
And Jason, if I could add something, obviously and you see the persistent engine level adaptation as critical, and also sort of the more advanced version of it. That doesn't mean that you don't need document level adaptation or direct matching. In fact, a lot of the time, it's actually how you combine the workflow around these that can produce the optimal result. Because a persistent engine adaptation is important to get the overall spirit, like Jason said, let's say that adjusted logarithm that really understands your nuances as well. But sometimes in a particular document, you may have some adaptation needed, and this is where you run into inconsistency within the same document, et cetera, where document level adaptation can also be important. But perhaps the order is that persistent engine adaptation goes first and then document level adaptation afterwards. So although they may be different technologies, it's actually how they combine with one another. And it was also one of the questions that came up that was, do we still need translation memories if we have the adaptive translation? And the answer is still yes, because although the overall spirit will be there, sometimes those exact words. So let's say the tool got Supreme Court of Canada, for example, as Superior Court of Canada, because in the training data, there may have been a level of confusion. So that's where you'd say, no, this is always as such. It's always as in the TM as such. So those are the types of things worth thinking about, but also that these models are also per specific language pair. So that like we have clients, for example, that will have different adaptive engines per language pairs, as long as there's sufficient data to train in each one of those language pairs. So the adaptive models don't transfer from one language to the other, but also they don't have to have a common denominator language.
Right, exactly. Good points. And so just the same way that statistical machine translation, rule-based machine translation, and neural machine translation still work together as an ecosystem, all of these technologies also do as well.
And Jason, I'm only going to jump in with this because I think it's a very appropriate question from the audience. That sometimes naturally the translators will make certain adaptations that could be wrong or imprecise, even within the same team, which will naturally influence a little bit the actual the adaptive version of it. So let's say you have a pretty good engine. There were some things that were done in a rush over a period of a few weeks. There could potentially be a temporary degradation. How do we avoid something like that?
In multiple ways. So one of the ways is that, so just like imagine that this data, these translations that are not right for your business, maybe they're not right in general, but maybe they're just out of context. Maybe they were done by a freelancer that's not as familiar in a rush, something like that. Imagine that they're part of the original training data. that's one of the big advantages to having adaptive translation in the first place, is so that this new, more accurate data can be used to replace that and to train over it. Just like the way that you would learn and train, that an employee would learn or train based upon new information that they receive and become better at their job over time. The same thing goes for an engine. And then there's also the situation where, imagine that the bad information is coming through at the adaptive translation level. That's where it's important to iterate, to monitor the iterations of the adaptive engine and make sure that something large and systemic is not going wrong. So that if something was happening where someone was intentionally trying to corrupt this engine, or not even necessarily intentionally, but doing something consistently wrong that was teaching the engine something consistently wrong, then it's important to sort of to use the language model, the large language model to, well, larger, we're about to use large language model as a term, but the original language model that's robust and trained with a lot of information about the language, to make sure that it makes sense, make sure that the content has the right subject verb relationships, to make sure that if numbers are present, then they should be present in both sides, these kinds of aspects. And if not, it's possible to roll back that specific adaptation, the one that is flagged as incorrect. And so it's important to constantly monitor that quality. And this is done by algorithms. It's done in an automatic way. But anytime that is detected, it's the best course of action is to roll back to the last safe model and continue your adaptation from there.
I think that was a perfect segue into our next topic and our next innovation. So very cool.
Yes, I inadvertently used the same terminology. Okay, so large language models. These are something that as we mentioned in the intro, they are very popular because of the power that they're bringing, and the changes that we're seeing to this technology that's rapidly advancing it. And so, in much the same way that a neural machine translation engine is using deep learning, this is a way that an engine is trained on enormous amounts of data. A lot of the time, the actual training data itself is monolingual. So it's not learning to translate specifically. And I kind of mentioned that in our last session, that translation is something that a large language model can be asked to do, but it's not what it was trained to do. It's not its function, and as such, it's not always the best at it. And so what the large language model is focused on is actually learning about individual languages and the meaning of those languages, the context, the intent, and really trying to determine what makes that language correct. What words go together and should be clustered together to obtain a certain meaning, which words in similar sentences have similar meanings to one another in the way that they're used, all of those kinds of things. And so the core advantages is the ability to really understand individual languages and manipulate them in some way. And so the examples that we mostly see in today's world is by giving them some sort of prompt, asking them to do something, and then they'll give you a response back based upon the information that it's been trained upon. And so this is using the transformer model that we mentioned at the end of the evolution of machine translation slides in session 1. So this is a purely attention-based mechanism. There's been a few different advances. Google's BERT was a pre-trained model that was launched in 2018, and that is a categorization model, but it's trained on such a large amount of data that it was widely adopted across a lot of different natural language processing methods and mechanisms, and used in a tremendous amount of machine learning. And so these large language models, they definitely they have a specialty, and that specialty is understanding the meaning and context of certain language. You want to go ahead? I have more on this topic, of course.
And Jason, just just from a definition perspective, because I know transformer here, and tying it into sort of what people are colloquially used to ChatGPT, the generative pre-trained transformer. Do you want to sort of just tell the audience that what it's referring to? Because I think the sort of making the connection between large language models and how they can turn into generative AI can sometimes take a little bit of the understanding on its own.
Yeah, certainly. And so it really comes from the quantity of data and the way that it's trained. And so in stark contrast to what we were talking about with adaptive translation, these are those models that take millions and millions, sometimes billions of input data, and again, not paired data like we're familiar with neural machine translation, but largely monolingual data, some multilingual data, but mostly monolingual data, and then trained over the course of many months with tremendous amounts of hardware that has an intense demand. And so the generative pre-trained transformer, the GPT and ChatGPT, is not unlike the other generative forms of AI, like art and music that we had sort of mentioned before. It's a way that it's taking all of this data and finding different ways to return it. And so just like the same way that you would see for a generative AI that can create a story based upon all of the other stories that it has been trained upon, the same kind of thing can be used for modifying specific paragraphs or contexts that are not stories, segments that are within very specific contexts, as long as the model has been trained upon enough data with that context.
And Jason, if I may, one of the audience member mentioned specifically that LLMs are really good at understanding messy language, slang, spelling errors, and other models generally are trained with perfectly spelled words and perfectly made sentences, which is typically in neural machine training what we would see the higher quality training data, the better. And this is why the two work well, and it'll play nicely into. But that's a really good comment from the audience, as well as that.
Yes.
That that's why this. Often it's about combining this technologies versus saying is one better than the other. Like typically there's room for all of them to play in a sequence to work together. So we'll chat a little bit more about that momentarily, but I really like the engagement from the audience.
Yeah, that's really great. And it ties into what we talked about in session 1 in terms of early NMT had a sort of tendency to over fluency the translation. If the source text was not a well-formed sentence, and like intentionally, like maybe it was a heading, something like that, it had a tendency to turn it into a nice, fluent-looking sentence, even though maybe that's not necessarily what the translator would want, or what the user doing the translation would want. And same with ChatGPT or similar large language models, that if you've used it, you can probably experience this. It has a tendency to give you a lot of answer, and then not all of that answer is necessarily what you're looking for, but it gives you it errors on the side of more in terms of giving you that fluent response. So it's very similar, and we're at that kind of same point of evolution that we were when NMT was new. It had that tendency, and then it's gradually been pulled back. I think we'll see the same thing in large language models. So why use large language models to optimize NMT, or why optimize NMT in general? The question is, so it comes down to what the NMT model was trained on. So as Gary was mentioning in the question from the audience, if the NMT models, in order to be highly effective, need high quality data. And as such, they may not be familiar with all of the different ways that language can be broken. And so it's useful in some ways to have a sort of corrective mechanism for that. But it's also useful to imagine you have a neural machine translation system that's been trained intensively within a specific domain or context, and then you want to ask that model to perform in a different domain or context. You can leverage some of what a large language model has learned about that context in a monolingual way, in which to edit the translation to adapt it into a new context. And that new domain or context can be something that the original neural machine translation model was never exposed to in training, and often deliberately. The highest quality result for a neural machine translation system is going to be obtained when it's very focused, when it has a very specific domain and context. But you can still use that same NMT to perform different functions by augmenting it with a large language model. And so same with, imagine that the NMT system itself was trained on very formal language, contracts and documents of a very formal nature. If you wanted to leverage that same NMT to send a more informal email for like a internal communication or a marketing announcement, something like that, a large language model can adapt that existing formal NMT response into a more informal style, or any other kind of style. And so it's very flexible in that way. And then also sometimes it's you may want to leverage a large language model in order to obtain certain nuance that's not in the training data. So like imagine just like the more informal language that's used in like a chat or in conversation is different than the language that would be used in much more formal documents. And so large language models can also adapt the text to that kind of contexts. So yes,
Jason, I'm jumping in because one of the questions was, would language service providers, or we could even apply this to translation translation departments within organizations, would they train their own LLMs? And the answer is LLMs are very resource heavy to train, and so it wouldn't make sense for an LSP to go train a large language model. I think LSPs, internal translation departments, should have their own NMTs and adaptive technology for their purposes, and then optimize it, essentially use large language models to optimize that as that result. But certainly not creating large language models from scratch. A lot of data processing, as you can appreciate, and collection. So it would be hundreds of millions of dollars of investment or billions to actually do large language models.
Exactly. And by nature, they are broad and generic. So it's sort you're best served by sort of using them for what they're good at.
And we, in a way, because it ties into one of the questions that could LLMs be good as a reviser, in a way you are using LLMs to do a level of post-editing afterwards. So obviously the translator will still have to go post-edit, and you're still going to have a reviser go line by line to make sure you really have that optimal final product. The idea is to try to save the translator that's doing the post-editing as much time as possible by applying this second sense. Because they're also so good at understanding colloquial language, one of the biggest challenges with machine translation in general has been around marketing content and content that required a bit more creative language. This is where we could, by prompting the large language model in the post-edited context, you could actually get better results in that marketing sense. And this will be one of the optimal uses, language, or think of in financial institutions saying, I needed more simple language. Those are the contexts where you can really help do this more broadly versus having to go in and change sort of every sentence within it.
Exactly. Okay, continuing on kind of the same topic here. So when we were talking about how NMTs work, it's using the same sort of translator or transformer architecture. And so it's talking about taking the input language, turning it into a numerical equivalent, performing a bunch of different calculations on that based upon the trained model, and then returning a numerical answer that is then turned back into its text component. So, and sort of again, to tie into that question that we just got, it's trained on, by nature, it is trained on very, very large amounts of data, much more broadly than you would if you used the same kind of translation or same kind of data to train a translation engine. You would end up with a translation engine that was also very generic. And so it would not necessarily perform its function as well. But for a large language model, the larger amount of data actually serves it. And so when you integrate these two together, the large language model can be very useful for generating suggestions and alternative translations and alternative styles based upon the monolingual text itself. You can ask it also to sort of observe things in the source text and represent them in the target text. That is possible, but largely they're working from a monolingual point of view. And then let's tie it together here. So large language models and NMT together. This is where the way that you get the most benefit from this is by situating this large language model close to where the translator is doing the translation itself, or I should say the post-editing process itself. And so that becomes another tool that a translator uses, the same way that translators have come to use cat tools and also to use machine translation. This is another tool in the same way. If you are working in a specific segment and you need some additional help, this gives you alternatives to look at. It doesn't necessarily mean it's going to be exactly what you need, but it's another option that you can access. This is especially useful if, as a translator, you're working in a context where you don't have translation memories that are fuzzy matches. You haven't worked on these kinds of projects before, and so you may need to obtain alternatives without necessarily having your own body of work to refer to. So the responsibility still comes down to the translator to review it, determine the relevance, and take the best, apply it to the translation, and end up with a high quality result. But the end goal is to make that post-editing process, the existing post-editing process, to make it faster and more accurate, so that the translator has the most amount of resources at their fingertips to obtain the end result of the document. And then we're going to go into a little bit more. So benefits specifically to translators, as I mentioned, it's a tool for them. But for post-editing support, you can think of the original neural machine translation as a first draft. You could also think of a generalized LLM check of it as checking that first draft for quality. Much the same way that we've learned to use spell check and grammar check in various applications. This is a sort of another way to say, does the translation make sense? Before I dig into modifying it to my specific purposes, like is it a good translation to start with? Is all of my content maintained? Does it follow the right formatting rules? These kinds of things. It can also refer to language enhancement. This is where sometimes you have a translator that is part of a team, but they normally work on a specific type of document, and then all of a sudden a translator that normally does all of these other content in another context, like there's a medical translator, for example. You can use a large language model to change the context to sort of learn as a translator, to learn about what would a medical translator would have said here, and kind of draw from that and obtain that kind of different result. As a result, they're expanding their language skills, expanding their vocabulary within specific contexts, those kind of things. It's not uncommon for a translator working in a new domain that they're completely unfamiliar with to encounter terminology and ways in which things are translated that they are not familiar with, that they haven't been exposed to in their daily life or in their career. And then, of course, being exposed to different language patterns, idiomatic expressions, linguistic variations, all of these things ultimately lead to expanding or enhancing their own language proficiency.
And Jason, I'll jump in just with a couple of questions that have come up. So one of the questions was, what's your opinion about ChatGPT applied on translation? So these types of activities that we're talking about here, you could use tools like ChatGPT. I'm always concerned to the extent you can to maintain confidentiality, but for the sake of confidentiality aside, let's say you were working on something where confidentiality wasn't concerned. Some of these features you could do with ChatGPT. You at the same time, one of the other questions was, are large language models the same as machine translation? So a lot of the NMTs that are available on the market typically outperformed, based on the research that was done, outperformed large language models. So typically you'd use the NMT first, and then use this step as large language models for this post-editing step afterwards. Keep in mind what Jason talked about, the generative tools are repurposing existing technology. So typically you're getting some NMT somewhere being repurposed in that context. So you always want to use the LLMs. All the academic papers currently out are speaking to use LLMs for post-editing, not for the first draft, essentially. Especially if your first draft is highly customized with NMT to specific to your organization, to your team, then the delta becomes even more substantial from the LLMs that are available out there. And similarly, one of the other questions was, can you use translation memories and term bases to make the process more efficient? So you should always use translation memories and term bases, because when you find, as long as you're comfortable with everything that has been maintained there, and there has to be proper curation of those over time, just like we have been for many years since they came about. One of the things you would want to do is then train that into an adaptive model, as long as you have large enough translation memories and term bases, so that you can get a further leg up from that, and then ideally even apply a large language model afterwards. That's really the thinking. There was another question around whether we use linguistic validation by professional translators for the training. And at Alexa we do, but I know that a lot of and per the question from the audience, the industry has sometimes done it by strictly just using models without necessarily linguistic validation. We found that we produce better results with translators being hands-on in terms of validation.
Yes, definitely. Yes, exactly. So I guess you could think of something like a machine that works in a factory that's highly specialized in welding car frames, as opposed to trying to get a general robot that performs a bunch of different functions to do that. Even if it can, it's not going to be as efficient at it. It's not going to do as high quality of a job. Enhanced quality, time savings, consistency, and customization, primary benefits of large language models specifically applied into the post-editing arena for translation. And so this is where we've kind of touched on all of these, but this is just kind of sums it all back up. And so these are the benefits that you need to obtain if you're designing a system that leverages large language models. If you don't get all of these sort of different aspects, then the design is not the right design, because ultimately we want to make the life of the translator easier. We want to make the output more high quality, and we want to make the timelines faster. We want to make the ability to process more information much more quickly. So in summary, we've talked about adaptive translation, and then sort of tied that into large language models. The two technologies, as Gary mentioned, it's very important that we know they are very separate from one another, and they actually are a little bit, they're just entirely designed totally differently from one another, but they can be both used together to obtain the same goal. And so all of these sort of things work together the same way that all of the components that we talked about in session 1 work together, and all of the existing technologies of translation memories, term bases, tie into these things as well. The responsibility of the translator becomes to be familiar with all of these different tools and to use all of them for what they are good at. Lean into all of their different strengths and use those to obtain high quality translation.
And Jason, I think it's been really great to see the questions from the audience, and also the advanced understanding, which is heartwarming, because it is important to understand how this is playing in the industry. I know we're approaching time, so certainly some of the questions we'll pick up next time as well. But there was a reference to hallucinations coming up by large language models. It's a very real thing, and it'll be something to actually train the respective teams that you work with around how to be cautious around that. But and to optimize the result, you have for natural regional language adaptive translation, ideally with your own NMT, then with some LLM to make further adaptations after that. That would be my suggested best course of action.
Great. And then so we will get back to everyone who's asked questions that we didn't get to along the way. We'll get back to you on those. And so
Yeah, perfect. This is literally a perfect timing. It is 2 o'clock. Gentlemen, well done explaining a ton of content during this time. So I really do hope that everyone, and the questions were brilliant, Gary, to your point, a lot of great knowledge in the audience, really, really great stuff. And the questions we haven't got to, we definitely will. But just very quickly, just want to talk about next week. So very excited to see you next week as well for Module 3. And Module 3 is going to talk about how to successfully implement technology. Technology is only as good as implementation of it. So we're really delighted to have Kate Kreiderman, who is from Desjardins. She'll walk through a real example of really kind of how to successfully implement technology in an organization to make sure that it's completely and utterly successful. And then the last slide, Jason, is just for anyone else, if you want to note down our information, for any questions you may have in between the sessions, we're more than glad to take those. And yeah, we're very excited to get into session number 3 next week. And really, really thankful for all the great questions, great engagement. Jason, Gary, thank you for all that you provided today, and really hopeful that everybody has had a fantastic session number 2.
Thank you for having me again, Mickey. It was a pleasure doing this session with this audience.
Always a pleasure to have you, Gary. Absolutely.
Thank you, everyone.
All right.
Thanks,
everyone. See you next week.